Okay, so now at this point, what I need to do is I need to teach you a way that you can look at either a compound name or a compound formula and figure out whether that compound is an ionic compound or a molecular compound. And it's actually not too difficult to do. So maybe one of the things you remember is that you can subdivide the periodic table to a metal side on the left side of that red staircase line and a non-metal side on the right side of that red staircase line. And also you sort of have to remember that hydrogen, even though it's in the upper left, that is considered a non-metal as well. So you can't forget about that. So here's the basic idea. If you're looking at a compound and you see that its name or formula indicates that you have a mixture of atoms that are metals and non-metals, that will be an ionic compound. If on the other hand, you're looking at a name or a formula for a compound and you see that that mixture of atoms only has non-metals, then that is a molecular compound. And so what I want to do is at this moment increase the slide and go through some practice with this. So what we're going to try to do here is figure out whether these names and formulas are representing molecular compounds with covalent bonds between the atoms or ionic compounds with ionic bonds between the ions. And so the first thing you need to do is you need to have a periodic table for this, and you will have one for your test. And then you have to be able to draw a staircase line. I'm going to go ahead and do that. And so we go over here to boron, to the left side of boron, we go down and then over, down, over, like this. And I'm hoping you know by now, this is the non-metal side. But remember, hydrogen here is also a non-metal. And then the left side is the metal side. Okay, now we're ready to go. So calcium iodide, is that an ionic compound or molecular compound? And so what you'll have to remember is calcium here, you're going to have to remember its symbol. It is Ca, so that apparently is a metal. Iodide, it sounds like iodine, and so iodine here, its symbol is I, it's over here, so that is a non-metal. So we have a metal and a non-metal. So this is ionic compound, and it has ionic bonds. All right, so let's go on to carbon disulfide. So carbon here, its symbol is C, so it is a non-metal. So you see disulfide, ignore the prefix di, just look at sulfide. Sounds like sulfur, right? So here is sulfur, well, it also is a non-metal. And so we have a compound that is comprised of two elements that are both non-metals. And so this is a molecular compound, and the bonds between carbon and sulfur are considered to be covalent bonds. Now we're going on dinitrogen monoxide. And so again, with dinitrogen, forget the prefix there, di. Just look at nitrogen. Here's nitrogen. Monoxide, ignore the prefix mono. Just look at oxide. There's oxygen here. You can see that both nitrogen and oxygen are nonmetals. And so this is, again, a molecular compound. And the bonds between nitrogen and oxygen are covalent bonds. Okay. So here we have a formula. This is N2O. So again, this is a little bit easier. N is a nonmetal, O is a nonmetal. Just ignore the number of N's there are there for this analysis. You just look at the elemental types. Both nonmetals, so guess what? Molecular compound with covalent bonds. This is a little bit more complicated here, but the good news is for this analysis, we can sort of ignore the subscripts and parentheses. We don't really care about the total number of atoms on the compound. We're just trying to figure out what kinds of elements are there. And so you see aluminum. Aluminum is a metal here. And then we have phosphorus, which is a nonmetal. And then we have oxygen again, which is a nonmetal. So this is a compound with a mixture of metals and nonmetals. Aluminum is a metal again. And phosphorus and oxygen are nonmetals. And so this is ionic compound. And it has at least a few ionic bonds. Okay. So now copper chloride is our last one. And so copper here, its symbol is Cu, it is there. You can clearly see copper is a metal. And then we have chloride. There are two atoms there of chlorine. So here's chlorine. So its copper is a metal, chlorine is a nonmetal, and so this is an ionic compound with ionic bonds. Okay, so we move on. Okay, so now what I need to do is I need to talk about more formally what ions are. And so to do that, let's first step back and go back to thinking about what neutral atoms are. And so maybe what you might remember is that you have a neutral atom when you have an equal amount of positive and negative charges in the atom, because then they can cancel each other out. The only way you can have that is when you have an atom with an equivalent number of protons and electrons. And so when that happens, you have a neutral atom. Okay, so that's fine. So we move on. So as soon as an atom gains or loses one electron more, it is no longer a neutral atom. Instead, this is generally called an ion. Okay, we continue on. So let's look at some examples of where we're gaining an electron. So here we have a neutral fluorine atom. It has 9 protons and 9 electrons. And what it can do is it could actually gain an electron. So now you're still with 9 protons, but you're now up to 10 electrons. We have an extra electron. So that means fluorine now will have an extra negative charge, and we have to indicate that with a negative there. So when you have an atom with an extra charge, that is an ion. And when you have an ion with 1 or more negative charges, this is called an anion. Okay, another quick example of that, we're starting out with the neutral phosphorus atom with 15 protons, 15 electrons. Let's say for some reason this phosphorus atom gains 3 electrons, and so now we're up to 18 electrons. Well, we have a lot more electrons than protons, right? So we have 3 extra charges. This is indicated in the symbol here with a 3 minus, and so this is an anion as well. Now, let's look at some examples where you have atoms that are losing electrons. So for example, you have sodium. It starts out with 11 protons, 11 electrons as a neutral atom, but if it loses 1 electron, you go down to 10 electrons, then you can see you'll have an extra positive charge, which I've indicated in the symbol here. Whenever you have an ion with 1 or more positive charges, it is called a cation. So cation, there we go. And then finally, we have the example of calcium here. Starts out with 20 protons, 20 electrons. If it's losing 2 electrons, then we're going to have a case where we have 2 extra positive charges, and so it's 2 plus there, and so that is also a cation example. Okay, we move on. So one of the things you may have to do on a test is you might have to look at some kind of symbol for an atom or an ion and figure out how many protons, neutrons, and electrons it has. So let me walk you through how to do that. So for example, let's say you see something like this. This looks a little bit unusual. So I want you to notice on the left side here, on the upper left, we have a number, which is 27. But then on the right side, we have a different number. It's a number with a charge. And so let me remind you of something. Another way you might see it is like this. We have aluminum, and maybe this is 3 plus. And again, you have the 27 on the upper left, but another way you might see this is that you might see aluminum here has a 13 on the lower left. And this is just to remind you here that the 13 is the atomic number. I'm just writing AN here, which is the number of protons. The 27 is the mass number of this atom, but then you'll note there's a 3 plus charge associated with this atom. So that tells you this is not a neutral atom. This is an ion or a cation. And so here, we're just rewriting it a different way. We're just kind of leaving out the atomic number, and you'll often see that happen. But so my question to you is this: from this symbol here, can you figure out the number of protons associated with this atom that looks to be an ion? And so here you'll see the symbol is aluminum there. So let's look at a periodic table. You see we have aluminum here, and the atomic number there is 13. So that tells you that this atom has 13 protons. Okay, how many neutrons does this atom have? Well, what you do is you might remember that the number of neutrons is equal to the mass number minus the number of protons. And if you do that math, it's 27 minus 13, which is 14 neutrons. Now, how many electrons does this ion have? That's a little bit trickier. So you can see that this is not a neutral atom. It would be a neutral atom if I didn't see a 3+ here or anything else here, but we see a 3+ here. So that tells you it's an ion, it's a cation. That means it's missing 3 electrons. So normally, the neutral atom would have 13 electrons, right, to match the 13 protons, but it's missing 3 electrons. So now this ion really has 10 electrons. All right, let's move on to another one. So we're looking at the selenium ion, which is called selenide. Can you figure out the number of protons? Well, here you would have to look at the symbol selenium and see what its atomic number is. It's 34, so there it is. And so this has 34 protons. Now, can you figure out the number of neutrons in this symbol of this ion? The answer is no, because you're not given any information about the mass number. So we really don't know how many neutrons are in this atom. Can you figure out the number of electrons in this ion? The answer is yes. And so what you do is you say, well, the neutral atom of selenium would have 34 electrons, but you see it is 2- charge, so there are 2 extra electrons. So there are 36 electrons here. And so this ion here is got 36 electrons. Okay, let's do the next one. Now, we just have the symbol neon here. Now, we can look up its atomic number. It is here. There it is, and its atomic number is 10. So we know it has 10 protons. Can we figure out the neutrons in this atom? No, we don't have a mass number, so we can't do that. Now, can we figure out the electrons in this atom? Believe it or not, you can. You see, there is no positive or negative charge associated with neon. That tells you that this is, in fact, a neutral atom. If it's a neutral atom, there are 10 protons and 10 electrons, so there are going to be 10 electrons like that. Okay, last one. We have a copper ion. So we'll look up the number of protons by looking up its atomic number. Copper has an atomic number of 29. So there's 29 protons. There's no way we can figure out the neutrons because I don't see a mass number there associated with that symbol, so we don't know what that is. Electrons, can we figure that out? Sure. So the neutral copper atom would have 29 electrons, but you can see it has a single plus. That indicates that copper is missing 1 electron, and therefore this ion here has actually 28 electrons. Okay, well, thank you for listening to this, and we will see you next time.